So far we saw binary numbers, simple addition and subtraction of binary numbers, but human beings deal with base 10 numbers, and there is another way of the computer to represent those base 10 numbers, which is by using these BCD coding, binary coded decimal. We're going to see how to represent numbers in BCD, and we're going also to learn how to do arithmetic with these numbers. So pretty much what we're doing is using a 4-bit binary code to encode our decimal number to a BCD number. This is done by using the 842 coding or 8421 weighting scheme, and in this way decimal numbers are stored in computer using zeros and ones, but without the necessity of converting to pure binary. So let's see how can we do that. If I have my 48 in decimal, I'm going to use 4 bits per decimal place. So 4 bits for my 8, 4 bits for my 4. I'm going to represent the binary number of 8 and the binary number of 4. And I get this. This is 8 over here, and this is 4. And this is the BCD representation of 48 in decimal. So any decimal number is easily represented because with 4 bits I can represent from 0 to 15. In base 10 I only have 0 to 9 on my decimal places, so I'm good. And let's say that I want to represent an 8-digit decimal number. How many bits do I need? So if I have 8 digits, 4 bits per digit, I get 32 bits to represent that decimal number in BCD. So doing arithmetic with BCD numbers requires a few tricks, but we're going to learn all those tricks. There are 4 cases that we need to learn. Let's go over case number 1. Let's say that I want to add 46 plus 23, which the answer is 69. So the first thing that I'm going to do is to represent the BCD of 46 and the BCD of 23. And I get my 6 and my 4, and I get my 3 and my 2. And now all I'm doing is a normal addition of these 8 bits addition, and I get this as an answer. And if I convert this to decimal, I get a 6 and a 9, and my answer is correct. So case number 1, I don't have any problems with my addition. Let's now do a 46 plus 29. In BCD, I represent my 4 and my 6, I represent my 2 and my 9, and now I just do normal addition, and you get a 6 and an F. Well, F is not representing any number, is representing 15, but I can only represent one decimal number per 4 bits. So how do I fix this problem? Well, let's now add 06 to our result. So whenever you have a letter appearing on your answer, you need to correct your result, and that's done by adding 6 in hexa to your result. I'm using the hexa, but it can be 6 in binary or 6 in decimal, is the same thing. So let's see how do I do this. So I pick up my result, which is this one, I put it over there. My 6 is fine, so I don't need to do anything to that. I put a 0, and the place where I have my problem, which is this place over here, I'm placing 6. And now I apply a normal addition. And when I do that, now my answer is 75. And you got your right answer. Let's go over case 3. 57 plus 92. So I represent the 5 and the 7, the 9 and the 2. I apply normal addition and I get E9. I need to fix this problem because I get a letter. How do I do that? Well, we already know that we're going to add 6 to the place where we're having problems. So I pick up this result, put it over there, and add 6 where I have the problem with the letter. Apply the normal addition, and my answer is 149. That's correct. At last, as you're probably already guessing, case number 4, you apply exactly the same technique over here. you apply the addition, and now you get two letters. How do we fix this problem? Well, easily by adding 6, 6, 6 per letter. So you get your result, place 6, 6, apply your binary addition, and you get the number 124.